Can you walk me through how do we make ourselves cost competitive?
Real challenge why a lot of customers haven't seen cost savings by going to offsite as to still do the fragmentation we see in the industry.
What is the advice that you would give founders that are doing their first steps into the built world or robotics, anything that's really hard to do and that's innovating legacy industries?
It'll be the same advice I'm going to give them that I received from my manager when I was leaving Amazon, which was obsessed about the problem and not the solution.
Where did you get these skills? Where did you, how did Kiva and Amazon, foster your growth as a roboticist and as simply as as someone that thinks in terms of tech?
I think the surprising transformation that took place for me from Kiva and Amazon Robotics is that it made me less of a roboticist and more of a systems.
Hey everyone, and welcome to BitBuilders, where we sit down with the greatest minds building and exploring robotics in construction and space. Before we get started though, if you're a startup founder or operator responsible for innovation in your company, or you want a deeper, more insightful look into technology in AEC, you won't want to miss our newsletter. From deep dives into particular technologies such as AI, robotics, design, software, and so on. Hot takes from investors betting big in AEC technology and advice on building tech companies, including the stories and takeaways of the most successful AEC technology founders. Head over to www.bricks-bytes.com and sign up today to get this exclusive material straight to your inbox. And now for the episode.
Hey Vikas, how are you?
Doing well, Gabriel. It's great to reconnect again, and looking forward to this conversation.
Yeah, great to have you here. I'd love to, introduce you, but why don't you do it yourself? I think it's super interesting to hear your story. I've had the chance to do this in our last connection. So, for the benefit of the audience, Vikas Enti with us from Reframe.
Excellent. Thank you for that. Hello, everyone. My name is Vikas Enti. I started Reframe about 2 years ago with my co-founders, Aaron and Felipe. We've spent about a decade at Amazon Robotics, where we really learned a thing or two on how we scale robotic fulfillment solutions across the world. A lot of you today have same day or next day shipping with Amazon. You're welcome. A lot of it was the effort we put into scaling our fulfillment centers, right from the first one with 300 robots once we were acquired by Amazon. We were Kiva Systems before that, to having almost 500,000 robots by the time I left. But the reason we're here today, I think, is actually less so because of the Amazon story, but more so because I became a dad of 2 newborn twins, and we ended up spending almost 8 weeks in the NICU, where a lot of the time was just spent holding them while they were just feeding and growing, but also became a time where I actually got to do a lot more introspection, a lot more reading. And I read this book, Speed and Scale, by John Doerr, which completely clarified my thinking. Like, until that point, I kind of knew that climate change, carbon emissions, were going to be a more clear part of our life moving forward. I think we're nominally aware of the dates of like 2040 and 2050. We had to really get to net zero as a world by then. But none of it really crystallized onto like what are real solutions, like how do we actually go about solving it. And Speed and Scale really created this framework where it was like, hey, most of the solutions that we need to decarbonize our world already exist today. They just are not deployable quickly because they don't have the right mechanisms. And DC mechanisms don't have the scale to actually get them to be valuable. And the only way to solve this problem was to find ways to deploy existing solutions quickly and at scale. And so that kind of gave me a lens, because what I'd been doing for most of my career was doing things at speed and scale, be it deploying large complex systems, Amazon, trying to find ways to get more throughput there. So I started applying the lens to say, okay, maybe I can do something about helping reduce carbon emissions, because 2040 and 2050 are not random numbers anymore. My goals are going to be 19 and 29 for those years. So it's actually becoming more tangible. And so that question kind of led me down the search on, okay, but what industries can I start applying these skills that I have, where we can deliver solutions that allow us to decarbonize the environment, right, at speed and scale. built environment, right, has almost 42% of emissions. What was really intriguing for me was the fact that 27% of those emissions were coming from our homes. Our homes actually emit more carbon than our cars. But and what was, I think, pretty interesting too was the fact to decarbonize a home was actually it's all the existing technology. We know how to electrify homes. We know how to make it super energy efficient. We know how to actually get it off the grid and make it solar with battery backup. Like all of these building blocks already exist, but the path to deploy them at scale does not have unit economics path to it. Like building a traditional home is already super expensive. It's actually doubled in cost over the last decade. And to build a high performance all electric home that could be net zero, right, you're already seeing a 20 to 25% cost increase from the get go, from bill of materials to the higher skilled labor that's needed. But the fact is, we don't actually have the skill levels that are needed to build these homes. And so it very quickly became clear that this is actually a unit economics problem, which actually ends up becoming a labor productivity problem. It started clarifying for me to say, okay, I actually know a thing or two about how we fix labor productivity and address processes based on my prior work. And the problem became pretty aligned with my own interests. And very quickly, one thing led to the other. And I started building conviction that I want to do my part in helping decarbonize the built environment. And Reframe was born.
I love that. You know, we talked about speed and scale the last time we chatted. I ordered it on Amazon and got it the next day, so thank you. But I think that book, I'm halfway in, so thank you for that recommendation. I think that book really shows how the difference between an R&D project and a true scale deployment of something that needs to reach scale to actually have an impact. It's that step is really, really big. And in between that step, there's a lot of process optimization that you have to do. And you started out the process optimization by looking at the most comprehensive measure of what is the project looking like, the P&L of the project. And you start breaking it down to the atoms and seeing how can I optimize this atomic unit, or I can get rid of it completely and merge it with another. And we really kind of like broadly talked about this and how you guys at Reframe are thinking about this. So I'd love to jump right in and then go back at your time at Kiva and Amazon Robotics. I'm very interested. But I'd love to jump right in and ask you, what is your thought process of you sitting down the first day, looking at a construction, of a home kind of like cost structure and saying, okay, this is what we can optimize. How did you guys go about this process, and where did you guys land, and how did you progressively get to where you are?
That's a really good question, and maybe some more context for the audience too. So Reframe Systems, we're effectively building a network of agile microfactories that allow us to build low carbon homes, right? Twice as fast, twice as cheap, with 10x lower carbon. And the way we went about tackling this problem was, right, one, acknowledging that this is a complex systems problem. And the system is a sum of its parts. So trying to figure out like what are the building blocks for this cost structure. And what really caught my attention very early on was when we're starting to look at the breakdown of a home, right from the actual components, the cost of the materials, to all the building blocks of labor. The fact that 50% roughly of the cost of a home was the cost of direct labor going into it. And we looked at about 6 different pro formas that we had access to. And all of them kind of converged in the range of, right, like 50 to 60% was cost of labor. And that blew my mind, because the industry I've been part of, and if you look at any other industrialized environment, the moment you're starting to trend at direct labor costs being over 10%, so that's usually a moment to take a step back and say, hey, do we need to fix the design? Do we need to fix the process? Do we need to start bringing in layers of automation? Like, how do we not make the status quo and actually find ways to keep reducing the component direct labor? Because that's the problem that prevents industries from scaling.
10%. That's 10%. The threshold.
That's been the threshold we've operated at, right? I think depending on the type of industry you're in, especially if you're doing, let's say, more custom manufacturing, I think you have a higher tolerance for it. But if you're trying to build things at scale, because what it effectively translates to is, I mean, one, there's obviously a cost component involved, but more often than not, actually it becomes a scaling challenge because the things that scale easily are things that you can copy paste. So technology scales easily, but people don't scale easily. You can't always hire enough people. You can't train them up. You can't get the same skill level. So, and that's been a huge learned experience for us from Amazon too, is like any process that we had an opportunity to bring more technology and we leaned into it. But we can speak about that in a little bit. But going back to that breakdown, so like that's what stood out to me. So it said, okay, there's a huge opportunity here where even if all we did initially for version 1 of our system was just focus on improving labor productivity, right? Like rethink the process, rethink the design. Like don't worry about the materials. We think the material supply chain for construction is actually pretty robust. And the clarify here is like we're focused on light wood construction. It's called Type 5 construction in the US. And we believe the supply chain for the materials that are needed to build a low-rise home is actually pretty well established, that any change you make to that material supply chain starts resulting in pretty significant cost uplifts unless you can drive the demand. So we said, as a startup, that's a very high risk curve to get on. And I know you guys spoke to Mighty Buildings before, right? And there's a few other companies approaching the problem differently where they said, hey, we should attack the material problem first. And I think there's merit to that argument over a very long time mark. We made the counter argument that we eventually want to update the material stack to keep reducing the number of atoms that are needed to build a home. But today we need to reduce the amount of time needed to build a home and take labor hours out of it. And to do that, we've been very focused on how do we improve the actual process of construction. And what became really interesting as we dug into the process, right, it was like when you look at construction from the outside, it's very easy to think of this as, hey, this is a cycle time problem. Like you need people to be able to work faster, right? Like I think it's a normal tendency to say when you have to optimize productivity, you have to make the actual person work faster. So how do you give them a better tool? But what we learned as we looked through this process was it's actually more of a information interface management problem. Like people are actually really fast in the actual task at hand. If you look at a person framing a wall or building a roof or actually performing the whole myriad of tasks involved in construction, like each individual skilled person is actually really fast at the task at hand. But what actually makes them have a lower productivity is them having to get the information they need to do their job, to actually figure out how to get the right materials and the right tools in the right place. And that whole management of those physical interfaces and actually getting the information on, hey, like what is the actual design that's needed to be built. That's where we found that if you fix that problem, people are actually incredibly fast to perform the actual task. So a lot of the effort at Reframe has been on like how do we actually simplify the information transfer? How do we get to a world where we can go from digital pixels to parts really quickly with the least amount of intervention so that what we're designing in the CAD world and the BIM world is actually useful for the person building the actual structure. Today, the BIM world has been really useful for the AEC stack.
Hey listeners, I want to take a quick break to remind you about the Bricks and Bytes newsletter. If you're interested in learning about the technology shaping the future of construction, you won't want to miss the valuable insights we share each week. To get this exclusive content delivered straight to your inbox, head over to www.bricks-bytes.com and sign up today. Link is in the show notes. Back to the show.
I'd say more on the A&E stack, maybe a little bit on construction interface management. But the actual builders on the field or builders in the factory, depending on which way you're doing it, they really don't get to see the full benefit yet because they're still getting paper drawings that still look like regular drawings they've trained on. So it's very hard for apprentices to come in and do something different. And we're not getting the full benefit of the world that we've been able to unlock with BIM. So we kind of use the analogy to say, we think the world today has kind of gone from, hey, we had paper maps. We eventually moved to getting, hey, Google Maps where you would still print instructions or you would still do the mapping on your computer, print instructions, and you'd have a printed instruction sheet to drive. And I think that's where the world has kind of moved. They're using the digital world of BIM, but still getting to printed instructions that are not the level of rigor you actually need to do your job. Where we think we need to go to and what we're actually building at Reframe is how do you get to turn-by-turn navigations? Like what GPS did for turn-by-turn navigations that any person could actually get out there and drive and explore the world. How do we get to a similar construct where we can translate all the power we have from modern day 3D tools for designing our buildings and analyzing our buildings. How do we also extend that path to the actual manufacturing and assembly of buildings? And that's been a huge piece of our work, is how do we get those interfaces and that information to be seamless. So our instructions for our construction trades actually look more like IKEA assembly instructions rather than construction drawings. And that's been a huge unlock. So now we actually have a lot more apprentices who can do pretty high skill work and actually use that as a path to learn more about the industry versus having to learn a whole bunch of stuff before you can be truly effective. And that's been one piece of the information management. The other piece of the problem has been the interface management piece. And this is very relevant for us, especially because we're an offsite builder. If you think about most factories, right, be it in offsite construction or even the analogy everyone always hears about in construction, say we should build homes that may be mass-produced cars, because obviously automotive has figured it. But the challenge is all of mass production that exists today has gotten really good at building a standardized product. And the entire factory has been built around this world of how do you mechanically define the factory, hardware define the factory so you can build a single standard of a product, minimize variation, and kind of crank those products out. Construction, unfortunately, is a mass customization world. And if I speak specifically about the US, we have 7 climate zones, 50 different state building codes we have to comply with, and about 30,000 zoning jurisdictions. So it's a very long tail problem where you really can't get to, you could try to build one standard product that you can deploy, but you'll very quickly find that there's very few sites that actually work for it before you have to be compliant with all guidelines there. So we said, okay, so it's a mass customization problem. No technology exists today to address it, but it actually mapped a lot more to the world we came from Amazon, where all of e-commerce is mass customization. And the way we solved the problem was actually taking a software-defined approach. Like, how do you actually remove mechanical dependencies in the entire stack and make sure that everything can be software controlled? And our fulfillment centers actually ended up being a lot more simpler and flexible. And we said, okay, can we apply some of those concepts into how do we make our manufacturing a lot more software defined? And that's been the next big unlock for us on interface management. And I'm happy to, I know I've kind of given you a pretty long TED talk here, but let me stop there and see if you have comments.
But it's the TED talk that I was looking for, actually. Super interesting. I think as you were speaking, I tried to chart a mental model of what does reframe look like if you compare it to a mathematical function. And you have a mathematical function, you can call it reframe, open, close parentheses. And, what goes in, the inputs are, innovation when it comes to information. How do we represent information for our workers in our factories, which resemble more fulfillment centers than factories? How do we make them interface with those components? How do we move those components around, assemble those components? What is the hardware that is defined? It's actually the piece that I want to ask you about right now, but what is the hardware that needs to be there for these workers to maximize productivity, for the entire project to be as fast as it can? And then there's the material. And then the output is an offsite built, basically like a prefab construction that you can go and build on site. And that's probably the output part. Managing the output part has been already cracked by other companies out there that have already, drawn a playbook on how do you take an almost finished product and make it a finished product on site. And we've talked about information, we've talked about interface. What about the hardware that you have developed or integrated? And that's my question, to make this a reality. How have you thought about that design?
Yeah, no, it's a really good framing of the problem. And you're right that if you were to, the output of the function you're defining, right, like we're trying to make sure the output is still pretty consistent with the industry, right? So what comes out of our factories, what comes out of a reframe factory is still a volumetric module that's well understood in the industry. Our transportation companies know what to do with it. Korean companies know what to do with it. We can install them perfectly fine. So we made sure to not break that model. We have some innovation there in how we reduce the amount of material needed. But what our core focus has been on is inside the function, and let's call this the actual microfactory is the instantiation of that function, is how do we actually think about the interfaces and information management inside? And you specifically asked about like what is the hardware that we're working on that allows us to make this whole system tick. And to us, the hardware is also an interface. And there's two ways to think about it. You could take an approach where you say we have the information which is decoupled from hardware. So you have a process that is highly mechanical. You might have a person getting an instruction on one side and they work through the process and then they update the process at the other end. And that typically is the state of a lot of assembly line type of manufacturing where you're moving things on rigid conveyor lines. You have a state of the system. And all the software can do and the information transfer can do is not update the state of the system. It only can report back on has the system state changed because everything is still manually controlled and driven. What we did in our world was again, borrowing principles from what we did at Amazon too, was the first unlock was like, could we define and design a hardware interface that actually would allow us to transform this whole complex problem into a software problem? At Kiva Systems, which I was part of and we got acquired and became Amazon Robotics, we designed a mobile robot that allowed us to dynamically move what we call pods. These are basically inventory cupboards, for lack of a better word, that we could move around. But it allowed us to very quickly provide this physical world API that we could now dynamically challenge the robot to say, okay, bring me this product, and they would bring the product to a certain station, right, rearrange the floor, and so on. And the key principle there was it allowed us to break out of this mold where you had rigid conveyor systems that once you install them, like all you could do is monitor the state or maybe trigger the state in certain areas, but you couldn't dynamically rearrange it. It wasn't like a true way to interact with the physical world with software until the robot came into play. And so we borrow a lot of those principles because we've seen that really work in scale. To kind of come back and look at the modular factory. If you think about a typical modular factory today, and this has been very consistent, we've visited about 18 factories so far. We've spent almost a year plus studying this industry. I was at EIR at Eclipse Ventures, and that's how I also met Fundamental and Adam. And like what became really clear was like every factory in the world has a very similar process. Like they've all invested. And I'm ignoring the manual factories today. I think we're going to focus on what we've been calling modular tools, so factories that have a mix of automation and some technology already coming in, because I think that's the one step closer to the future, but they've got a few things we believe to be wrong, where they've effectively invested in similar assembly line technology that became very prevalent in automotive. And they've built, right, like every factory in the world right now has the same three-step process. You build a floor, you try to build your wall, and then you merge those as quickly as you can so you can build a box. And this box then goes in an assembly line and takes anywhere from 10 days to 14 days before it can get out of the building. And the piece of the system that makes the walls typically, and there's many suppliers for this, they've all made a decision for some reason that was like, we should all build a wall horizontally first. So everyone frames a wall horizontally on a framing table. That's how the industry started. And over time, they didn't change that architecture. They said the architecture is still the same. Like the wall has to be built horizontally on the ground where you only have access to one side of it. And then over time, companies have actually brought robotics to help with the framing, but then they still frame it horizontally. But what they've ended up creating is this really giant, messy structure. And ones we've been comparing against are roughly 25 to 30,000 square feet in size. Super long structures where you feed it pallets of lumber and sheet goods. Out comes a wall, sometimes an insulated wall, but takes a lot of footprint, but it's a very rigid process. Like it's dependent on these fixed conveyors. You have a lot of mechanical coupling with either pneumatic pins or hydraulic pins that can hold the studs in place. If it's a robotic system, even where the robots can actually apply nails and apply studs, all of these are really fixed. Like it's not truly software defined. It's like it's programmed. It's very similar to systems you see in automotive where they're programmed to execute repetitive motions, and you're kind of using that process to build walls, and that's like the biggest, most expensive part of the factory typically. And then you take up a lot of space to then very quickly assemble these walls into a volumetric box, and then then you kind of convert that into a construction indoors problem where you're creating the same challenge of multiple people having to get into a small bathroom to do all the different tasks that are needed. It's no different than on-site construction. So we've kind of recreated similar problems. In our world, we said, okay, we think the actual interface, the very first interface where you're building a wall horizontally and dependent on conveyor lines to move them around, we think that first interface is broken. So we said, like, why does a wall have to be built horizontally in a factory? Like, a wall's purpose is to stay vertical. We start building it horizontally in today's systems, and you spend all these hydraulic equipment. Like every factory we go to, they try to show off this system called a butterfly table. And we think that's actually the most inefficient way to do things. Like they spend all this time building the wall horizontally. They spend all this space and the equipment to install this hydraulic system to then flip a table, to flip the wall from one side to the other. So now they can work on the other side of the wall, and then they flip it back again vertically at the end. So most of these factories have a lot of these fancy flipping tables. And it was all of that was a symptom of the fact that they picked the wrong architecture of building a wall horizontally. In our world, we said that interface is broken. Like a wall has to be built vertically. And how can we keep it vertical through its entire life cycle? And how can we move it around without needing any of the physical conveyors? Because once you have conveyor systems, you get very mechanically defined in your factory and very rigid. So we made that first question actually unlocked a lot of value for us. Because now we said, okay, like our whole goal is how do you frame a wall vertically? It allowed us to start rethinking the entire system for how we frame it. So we've developed, right, using off-the-shelf robotic hardware, but custom end-of-arm tooling that's proprietary, but a lot of software and vision-guided algorithms that allow us to now frame a wall vertically and kind of keep the wall vertical through the entire process. We have a very simple invention called a panel cart. We literally attach wheels to the wall, keeps it vertical, and we can roll it around in the factory. So we've gotten rid of so much conveyor equipment, but it's also allowed us to rearrange the factory layout dynamically. And now we can actually have software instructions that all of our carpenters use iPads that actually get their instructions on. They're able to perform tasks using the instructions. They're able to track the status of certain work pieces in the factory. They kind of know where to move these things around, right? So it's become a very quick and low-cost way for us to get a physical wall API by kind of rethinking the framing system to be our software-defined robotic framing system, and then kind of providing this tablet interface to our workforce in the factory, where they're then able to actually perform a lot of the tasks that are software direct. And that two-step approach actually allowed us to kind of convert, right, like break the physical wall interfaces that were very hardware defined into becoming software defined, and then kind of creating this path where we're now able to directly send instructions from our CAD models. So we use Onshape for our CAD system. We actually are deviating a little bit from the industry here because we found limitations with existing BIM platforms. Like we tried building our first project in Revit, and we built the first one in Revit, but we found a lot of limitations in how we could then transfer information from Revit because the whole world is parametric, and we were having to do a lot of things that were non-parametric in Revit. So we made a decision where we still let our architects.
Sorry to interrupt you. What do you mean by that? Why? What was wrong with Revit's like unit architecture of being parametric?
It's so the parameters you get to adjust in Revit are still tied to the relationship of geometries and dimensions of geometries. It doesn't have a concept of assemblies and mating relationships that are actually the real meat you have. So let me give you a tangible example here. Let's take a bathroom or a wet wall. There's a physical relationship between a PIX pipe that runs through a stud that has to then connect to a fixture. In the Revit world, there is no association between or mating relationships there, right? I think right now it's only still an assembly of geometries. So if I decide to change the location of the fixture, you're still having to do a lot of work either in scripting or manually having to then reroute the systems, and also not just to reroute the PICs, and you also have to relocate the holes where we're going to re-enter the studs at different places, right? So it's a lot of work that Revit wasn't built to do. But this is the bread and butter of CAD systems for mechanical design, right? So be it SolidWorks or Onshape or CATIA, where you're able to build mating relationships and actually adjust this entire assembly to be able to dynamically reconfigurable. And that's the world we want to be in, because if we don't do that, then we fail at getting to mass customization.
Yeah.
Because there's so many nuances, right? Like there are simple times where certain jurisdictions won't allow us to use PEX piping. We have to switch to copper tubing instead. So how do you make that flip and then actually realize, right, you can't turn copper, the bending radius for copper is not the same as the bending radius of PEX. So the way you route that system looks very different. How can we build a system that's actually flexible in the digital world so that we can actually swap those out without having to manually redesign stuff? So we've had to make that decision. So it's a good tangent. So kind of going back to how this all ties back to the interface, we've now been able to build a pipeline where we can design our system, right? Concept designs in Revit, switches to Onshape, where our algorithms actually can create the framing patterns that are needed, populate the bathrooms and all the mechanical systems. And then we can actually translate these into instructions that go into the iPad screen. So if I'm building a wet wall, I don't get a 2D construction drawing. I get a step-by-step instruction on, right, which pipe to use. It's a 3D model. It looks more like a Lego assembly instruction manual rather than construction drawings. And the same instruction set from Onshape also goes into our robot. So right now, the robot's actually to translate the framing patterns we have in Onshape into a wall it can frame. Eventually, we can also start doing ceilings and floors. Today, we're focused on walls. And then we've also built similar interfaces where we can also output stuff from our Onshape model into, like, CNC routers have been established, right? That CAD-CAM interface has always existed, but not so much from for wood manufacturing. Like, that interface had to be rehardened for us. Same thing for CNC saws. But today we've kind of got into a world where we don't need the 6 engineers that you typically need to translate these design models into manufacturable models. You've been writing feature scripts inside Onshape and kind of automating the entire process. And that's where we've got into a really good compression of our value chain from how we go from pixels to parts. And we're going to keep building out that.
The analogy that you made an analogy on physical APIs. And I think for the benefit of the audience, not everybody might be acquainted with the concept of a web API. The general methods or functions of a web API are post and get. And like, post is do something, change the status of something, and get is look up the status of something and return it to me. And then the analogy that you've made, if I understood correctly, is that the post side is the easier part, let's say. Sorry, the get side is the easier part.
Right.
You just want to know the status of the system, right? So has my robot completed the job, right? And you might get control loops that say, yes, the wall is finished. You know, you can go ahead with the next one. That's inference that you have to do yourself, but that's the information that it provides to you. And then the post side of that API, that's the actual really difficult part, because you're saying to your whole system, and if you call the entire microfactory, or at least the pod that you're using, your system, you're telling it, hey, do this, meaning not do a series of commands that I've already, pre-taught you how to do. Simply reach that outcome. And to reach that outcome, there's a bunch of parameters that need to change in the robotic system that has to act on the physical substance of what we're moving around. And so it's really interesting how you build that get post internally. And that by itself might be a great idea, except it's just a means to the end of shipping out these homes faster and cheaper than anybody else. So I love that thesis. And what I'd like to understand is, before stepping into what does that mean commercially, what does that mean for our business model at Reframe, where do you see the biggest infrastructure, like the lack of infrastructure? Because it seems to me that you guys have been building a lot of stuff internally to do this. And it's like a very proprietary, puzzle of scripts, robots, people that know what to do, people that don't know what to do, and with a really smart way to tie everything together.
Yeah.
What was the infrastructure that would have been, building Reframe much simpler?
That's such a good question, and also loved your post versus get analogy. I'm going to use that in a minute.
Yeah, you're
explain this again.
I'm not going to trademark it, I swear.
Right. Yeah, so I mean, it definitely sounds like we've had to build a lot, but I think what's important to understand is we've only had to build a lot of the interfaces between the systems. Right? So we didn't have to develop a brand new CAD system, right? We didn't have to develop a whole new robot, right? I think we've been able to use a lot of commercial off-the-shelf systems. What we've had to actually build is how do you interface these things together seamlessly and actually have those interfaces be truly digital and software-driven versus having to have a person, right, copy a file or walk with a USB stick to go plug it in. Right? Like that's actually a real case story for what happens in most of the factories today. What would have made our life easier? I mean, if there's one request I could make is if the Autodesks or the Dassault Systems or any other CAD system companies out there or companies that you guys have invested in, if they can start finding a way to seamlessly translate AEC digital data into parametric CAD, right? That's where we've had to spend a lot of cycles to figure out how do we think about our data stores as an example. So that's been one gap. I think we're seeing the name of the company escapes me now, but I know they're trying to build a way to seamlessly interface between IFC BIM files into other formats. But that whole information interchange between different CAD systems early on, I think that's where we've actually spent a lot of cycles trying to figure out how do we make that seamless, or at least find a way to keep a bidirectional sync. In terms of physical wall infrastructure, a lot of invention has been needed, right? Like one thing we've been very clear about and trying not to make this a materials problem for us is how can we buy a pallet of lumber from Home Depot? Like the whole directive for my design team has been, how can we build all of our homes by just going to Home Depot and buying the components we need there? Like, so no specialized material. So that's been very deliberate because we believe their supply chain is actually pretty robust. And I mean, we don't have to buy from Home Depot. We have more specialized local lumber yards that provide us our material, but that's been like a good ethos. So what this has really done is it's forced us to solve a really hard challenge, which is how can we make our robotic automation system work with dimensional lumber that is an organic material, not dimensionally accurate, has high variability, and the variability changes based on humidity during the day. And I think that's one place where we've actually had to invent, right, our whole end-of-arm tooling, our vision algorithm stack for how do we how do we detect any change in curvature of the lumber. And so we can also, we have the super cool move the robot can perform when it tries to mimic a master carpenter. It has a regrasp move where if we place a star, we detect that it's actually not perfectly straight. We can actually regrasp it, straighten it, and then apply the nails. And that actually super cool from a technology side, but very fundamentally needed from a business standpoint, because by doing that, we can still buy materials that are cost competitive to us compared to traditional on-site construction. A lot of other modular players in the US, especially because the quality of lumber in the US is subpar for automation, end up actually importing a lot of lumber from Europe. They're buying containers and containers of lumber so that they can run their windmill machines off of it. So they're paying a premium on the material price there to make sure the systems can work. And then, so that always leads to then this other symptom we've seen on the business side, which is offsite construction isn't always cheaper because you're having to do all these other things to make your work, that you end up being faster but not cheaper. And in our case, the whole goal was how do you be both fast and cheap, because that's the only way to kind of move and scale the low carbon solutions we have. And so there we've had to unfortunately build our own interface on how do we interact with our physical building blocks that are not dimensionally stable. But if someone could make sure US lumber was a lot straighter, we would love that. So,
well, weirdly enough, we have seen also companies trying to make that happen. It's like trying to improve the quality of the US supply of sawn lumber boards, which is a huge part of the problem, for example, for furniture manufacturers and people that really care about visual finality, less so for structural lumber. But that's really interesting. But that's just a different rabbit hole. I want to try to get to what you just said, which is building offsite doesn't necessarily mean building cheaper, because building on site has been the standard for thousands of years, right? So we've been developing ways to limit costs and streamline operations. I can think of flexible schedules, the simultaneity of different trades. Where do we operate at the job site with which trade, so that we can build the fastest and we can do as many things in parallel as we can. How can we manage arrival of material to the job site in a way that basically we don't have to store inventory, and at the same time it's just last minute delivery. It's perfect. We're very far from having this run smoothly. I believe the construction of data centers, for example, is going to be a big catalyzers for this, because the people that are actually commissioning, and I talked on the podcast with Henning Rodell about this, the people that are commissioning these data centers do not want to wait. Meta does not want to wait. Google does not want to wait. Amazon will never wait. So they will be funding a lot of these technologies, or at least putting their own resources at disposal of the construction companies that are making these projects happen, so that this can happen. But still, there's a strong case for offsite construction, because obviously we can borrow a lot of principles from the manufacturing industry. Can you walk me through how do we make ourselves cost competitive, just staying on paper, right? How do we make ourselves cost competitive with on-site construction first? And then how do we just beat it for the segment that Reframe is tackling?
No, it's a really good question, and I think you covered it pretty accurately in terms of, right, like some of at least the way the industry has optimized itself for on-site construction. You get certain advantages there, but all of those advantages also exist in off-site construction, right? So we can also do last-minute delivery and not store, or we can save by ordering in bulk, minimizing waste, right? I think there's ways for us to keep optimizing it. But the real challenge why a lot of customers haven't seen cost savings by going to offsite has to still do the fragmentation we see in the industry. The current engagement model today for most customers who are trying to leverage offsite, they're still having to hire an architect, a GC, and then work with the factory. So they're paying for markups on all three stacks. And what we've seen with comparative models is, especially if you're doing, let's say you're doing a volumetric modular project, like the factory actually is quoting you a pretty compelling price. But now you have all these trades that are needed at the end of the process to actually integrate the building. It's usually their markups are what are starting to erode a lot of the savings that the factory can deliver. And that became a key observation for us, right? So when we were spending time building our thesis for Reframe, we built very conviction quickly there that the only way to deliver a superior outcome for our customer was to own the entire customer experience. And so we kind of have this saying internally, which is like 1 + 1 + 1 is actually equal to 10. Like we need to compress our value chain and deliver the whole compressed value chain to our customer. So in our case, we're one of the only few modular factories out there that not only designs and manufactures the building, we also install the building. So the way we sign our contracts with customers is we're not in the business of selling boxes. We're in the business of building homes. And we will work with our customer to make sure that we're signing up together to deliver the outcome of a home being built faster and cheaper. Our contracts are equivalent to almost a GMP type contract. And the reason we're able to do that is, one, we're customizing product platforms we're building off of. We're not building a highly custom product. We're customizing our product to make sure that if you're buying a single family home or a duplex or a triple decker, we're customizing our product to fit the site conditions, the zoning, so it's actually compliant. So that gives us a lot of savings on the soft cost because we're not having to redesign the building every time. But the place where we're actually driving a lot more savings for our customer is by just the sheer fact that we're also our own GC and we're our integration crew that's actually able to take it on. So by doing that, we've noticed that, we're actually, instead of having to pay 10 to 12 different businesses to deliver the home, you're paying the markup for every single business. We're actually able to kind of compress all of those markups pass a lot of those things as savings to our customer. And I've got some tangible examples here for what we realized even in our first project. Our first project, we still hired, because it was the first one, we had a third-party GC own the on-site construction piece. So prepping foundation, getting utilities taken care of, but we still took care of the actual integration. So we had our factory crew go on site for this first project to integrate the structure. So we got a good experience on where did we pay a markup on things, right? So we obviously paid the 20% GC fee, even though we actually took all the risk and handled most of the projects. It became very clear. So we've hired our own internal site supervisor. So for the next project, we will be our own GC. We're already finding ways to reduce our cost structure there. But in this first project, the place where we actually able to drive a lot of cost savings that also allowed us to build more conviction on the markup model was deploying solar. So we were quoted $30,000 to install solar panels on this home. This is it finally got certified as a passive house zero home. And when we did the analysis of the actual bill of materials was only about $9,000 for this panel. Why is it $30,000? And then the supplier came back and said, well, like our labor cost is another $12,000, and then we have our general business markup, et cetera, gets us to 30, but then you get a tax credit, so you're only paying 22, et cetera, et cetera. We were like, you know what, all of that's well and good, but what if we bought the components directly? We installed it all by ourselves. All we need you to do is just commission the system, because we don't have the licensing today to commission the system and connect it to the grid. And so they very quickly understood what we were trying to do, and then they worked with us to actually come down to a price point where, right, we actually drove their cost down to about $17,000 to $18,000 versus the $30,000. We're actually able to pass those $12,000 of savings directly to our customer. What we're realizing more now is that we can actually deliver the system a lot more cheaply for future builds, because we're basically compressing the value chain where we're trying to eliminate markups across a lot of the subs, where we can actually deliver a safer and a more superior product. So in our case now, when we do solar install, we can actually avoid the need to work at heights in the factory environment. We build our roof as a separate cassette. It's at waist height. You actually install your all the hardware you need to mount to your panels. We're starting to talk to a few suppliers where we can get solar panels that are actually qualified for transport. So that way we can also pre-install the panel in the factory itself and almost completely eliminate the need to work at height on the job site. But all of these things have kind of come back from us asking the question on like, why do these things cost so much? And what we've noticed sometimes is like the current operating mode in the industry has been like, you're not challenging the cost buildup. Like all you're doing is you need to get 3 bids. So you get 3 bids. The bids might be 28, 29, 30,000. You'll pick the $28,000 person, you go with it. But if you actually go back to the basics and like, why is it $28,000 or why is it $30,000? We're very quickly finding that there is a lot of value kind of hiding in the markups that are getting passed on. And markups aren't bad. Those businesses obviously have to succeed. And I think that makes sense if you're only selling the solar system to an existing homeowner. But in our case, where we're trying to build a full home, we think we can actually eliminate a lot of these markups and pass those savings on to our customer. And that's the first place we've seen a pretty big, let's say, contribution to our cost curve. And then the other places we've been able to then build up on that value compression has then been, okay, how do we design our actual components for manufacturing and assembly? And this is a very key unlock. If you think about a lot of the opportunity today, right? So our goal was use the existing materials, but use these materials in a smarter way. So like, how can we create datums and design features that are very common in manufacturing? How can we bring those into construction? So that way, when we have to have our wall mate with the floor, we already have pre-locating pins that allow us to snap the wall in without having to pull out a measuring tape. And our whole goal for DFM has been like, how do we get to a process where there's no tape measure needed? So that way, like everything is right, like is very intuitive on how things should come together. And then we built off of that DFMA platform. The third part of our algorithm has been like, how do we industrialize the workflow? And here we've been doing a lot of augmentation. So today we actually unlocked a capability in the last week because we commissioned our CNC router finally. We've been using the router with a few other custom add-ons, so we can actually print instructions directly onto our sheet material. We were already able to do this on our lumber for cutting, but now we can do a sheet material too, and that we think is the ultimate simplification of instructions, right? Like, don't look at a separate interface to figure out what to do. Like our wet wall, for example, like all the locations of where the pipes have to go, effectively the entire annotations are actually directly on the sheet material. Our customers don't see it, but our builders get to see it and actually build on it without needing more instructions. And we're applying a lot of techniques there on how do we do physical augmentation onto the material we're using, or digital augmentation with the iPad screens that we have. We've also implemented some pick-to-light systems. So there's a lot of component confusion when you look at plumbing systems, electrical systems. Plumbing, especially for us in the US, because sometimes you've got both 3/4 inch pipe and 1/2 inch pipes that exist in the same wall assembly. And visually, it's very hard to tell the dimensional difference and having to bring. So there's a lot of rework involved and just frustration. So we've been using pick-to-light systems to guide our builders on which components to pick, but it's also giving us closed-loop control on quality. So the industrialization workflow is a place where we see significant value to continue improving the quality of our build, but more importantly, start bringing a lot more apprentices in. Right? The whole mission for that industrialization workflow process is how do we supercharge apprentice builders. And we already validated this in our first build. We had 60% of our builders were apprentices. It was a 5-person build team. 3 of them were apprentices that actually got to do plumbing and electrical work based on these instructions. So we know there's a lot of merit to this approach that we're going to keep supercharging over time. And then the last piece of our algorithm, right, and it's a little counterintuitive because everyone thinks that we started with a robot, but actually that was like the last piece, which is okay. Now that we've compressed our value chain, we've optimized our design for manufacturing assembly, now we've industrialized the workflows. Now what can we automate that actually allows us to meaningfully remove labor hours from the equation? And that's where we built the robotic platform that we spoke about earlier. And to us, it's a platform, which is a key operating term here, because we've chosen to use this platform for wall framing application today. It extends itself pretty nicely to do other structural applications, right? So be it the ceilings, the floors, we're also finding ways to assemble our cabinets and stairs using the same building blocks of that platform. But we're also finding ways to extend the stuff we're building on that platform. We're starting to build a second robotic platform for mobile manipulation. So we're looking at drywall finishing and painting applications. So we actually validated that with an intern this summer. So post-Series A, that's another part of our technology stack that we're going to harden. And that way we'll have a fixed manipulation platform for bulky structures, a mobile manipulation platform to take care of finishing tasks initially, but there's a whole bunch of inspection tasks, there's a whole bunch of air sealing tasks that are all needed that we believe that platform can serve really well to perform that. But that is the last part of our consideration. So we're not a robotics company, we're a systems company. And we believe that we need to get this entire stack to work together to drive the full value that's needed. And that also plays into some of the commercial considerations for how we think of ourselves as a business.
I believe a lot of companies will succeed when they see themselves as system integrators, and many others will find a very kind of like tight pipe when it comes to only robotics. Meaning, we are seeing a lot of companies that are delivering value by using robotics in tasks that were not robotics. Earlier, that basically they're substituting human labor with robotics, but the business models that work for now are the ones where basically you are hired as a trade contractor. Most often it happens. Yep. You're selling the outcome. You're not selling the robot to trade subs or to GCs, even less so.
Yep.
That might change as people basically start getting very comfortable with the idea of using machines to do work, semi-autonomous machine to do work, because we use machines to do work all the time.
Yeah.
They might change, but it will take a decade or so for basically my generation to become the general manager of these, legacy trade subs that are probably inherited from their parents, and change completely the way they work. And instead of, looking at how do we optimize payroll, they would actually look at, hey, how do we optimize the CapEx that we take on buying robots and certify our labor pool, needing a third of the initial labor pool that we have, and build more efficiently, and then sell the outcome for the same amount. So that's the shift that's happening in the industry. It's going to take a while to make it work, and I think some of this work will be done by startups. Some of this work will be done by tool manufacturers. Some of this work will be done by general contractors that are really innovative, and they will give room and breathing air to these companies. And again, that conversation with Henning was very informative with what DPR is doing. But there's a lot of other companies that are really just innovators in the space. The things that will not change is probably how do you get your business and how do you get in touch with customers to build new stuff, and how do you pitch lower prices with slightly higher risk. And the risk is just reputational risk. It's nothing, I think I can imagine that if Reframe is doing something and it doesn't work the new way, I think the fallback emergency plan is to do it the old way. So the outcome will be there. But how is Reframe going about getting new business? Because you guys are selling homes. There's a lot of competition of people that are selling newly built homes. So what's your plan?
Yeah, it's a really good question. And I really like a few of the things you said. Is I think we're all in the outcome business. Like, how do you deliver outcomes for customers? Like, I think the technology is a tool. And I think that's been pretty clear in how we've defined ourselves and how we think about our mission and the value we want to deliver to customers. There's a couple of nuances here, right? If you think about the construction industry, all the sophisticated GCs are typically working on commercial construction, right? So they're building the data centers and the massive factories and maybe some high-end, like large multifamily buildings. But the bulk of the homes, so in the US, for example, about 1.5 million homes get built every year. Of these, if you think about the top 250 home builders, right? So the top 10 are building almost 10% of these homes, but the rest of them are building, right? In the top 250, people are still building a few hundred homes a year. But the reality is there's another 10,000 builders who are building the rest of the homes. They're building 2 homes a year, 3 homes a year, right? So the industry is extremely fragmented. And what you see from a technology penetration standpoint and a capability standpoint is that the Lennars and the D.R. Hortons and the Pulte's and Toll Brothers on the home building side, and maybe Greystar, they have access to the capital and the tech and the sophistication to run that. But your mom and pop builder, who is a local builder, who has a local reputation, they don't have the resources to go take that on. And I think we're going to find that even as more and more companies bring technology into the market, like getting penetration, especially in the home building world, is going to be hard just because of how fragmented the industry is. So to us, that was also informative because when we were starting our business, right, like there were 2 business models we were trying to reconcile. Are we going to be this turnkey builder where we're delivering the outcome of a home? Or are we going to be the technology provider who's going to help other builders build more efficiently by providing them the software and the factory and all the systems that are within it? And where we finally built conviction that we had to own the outcome of building a home was because of how fragmented the industry is. Like there's very few players who actually have the resources to take on the challenge of implementing tech. But even for those players, we realized that a lot of these big builders are actually not really constructing. They're effectively sales and marketing companies that own land. They subcontract all construction to subcontractors who are then performing all the tasks. So in there, we built conviction that even for us to be successful in selling to some of the big builders, we're actually going to be more successful in giving them the outcome that we can deliver a constructed home a lot faster and a lot cheaper than having to sell them the building blocks so then they have to figure out and operationalize. So that provided us a conviction that like we had to be in the business of delivering the outcome of a finished home and also be different than other modular players and actually like thinking out of the box. Like we can't just be selling boxes. Like that's what the whole modular industry has started, right? Kind of built itself around. They constrained the customer to think about their entire design in boxes, right? The whole floor plan's constrained to the box dimensions. Like the whole industry kind of streamlined around this box architecture, and we've been trying to break the boundaries of the box. And we said, our goal is to deliver a product that customers will love and that our customers' customers will love. Our customers are developers who are either who are working with us to build homes that they either sell or rent. So we want to make sure that 1, they love the pro forma they get from us, but 2, that their customers actually want to buy these homes or rent or live in these homes. Right? So we're really focused on that quality. So we're working back from that. So we're like trying to figure out like what's the right floor plan and the right living experience for those customers. Then how do we make the modular building platform fit that mold? And that's forced us to think literally out of the box, where we've been starting to design our systems where we don't need a 6-sided box that we transport down the highway for 5 hours. We're starting to design 4-sided boxes that are not wide loads, that we know we can minimize material wastage and doubling up in how they come together on site. The fact that our whole business model is to deploy micro factories are right within an hour to 2 hours away from most customer sites that we serve has also allowed us to rethink the transportation logistics challenge, so we can still focus on delivering that high quality outcome without the customer having to worry about all of our constraints of doing business, right? So they still get the end piece. And the other salient thing you said was, how do you also keep a relief valve that isn't expensive? And that's been critical. It's a huge lesson even for us from Amazon, is like, don't wait till everything is perfectly ready before you start adding customer value. Like, how do you keep delivering customer value incrementally and continuously? And so even here, right, we made the call to not fall into the trappings of a lot of other startups where you spend a lot of time building your prototype that you can show off. That's not a real living prototype. And then you try to bring that to market. In our case, we very quickly said we have to sell our project as quickly as we can and build a real home. Use that as a forcing function to keep maturing our technology, but not be dependent on the technology being fully ready before you deliver that home. And that was a really good forcing function because it taught us so much. Things that I wouldn't have envisioned as real challenges in trying to get through the entire certification process, the zoning reviews, the actual reviews with our customers, lenders, and right, so the entire stack of financing to contracts and warranties and all the things we had to think about. And we've learned all of that, right? So as a business now, we've built our first home. We've actually unlocked all of those lessons so that now we can actually start scaling. And what this has also allowed us to do is refine the requirements of the technology side. So we haven't had to build the technology in a vacuum without intersecting a real world problem. The advantage we have in our architecture, because everything is software defined, we're able to make changes pretty quickly. Even if we made a bad choice in a hardware interface, in fact, we constrained our first end-of-arm tool for our robot. We very quickly learned that wouldn't work. We're already on version 2 of our end-of-arm tool. We're able to make that change in less than 3 months because a lot of the complexity is still pushed in software, right? So I think that architecture that we've built allows us to be truly agile in how we can keep improving our building platform, our manufacturing platform, to keep delivering value to our customer. And I think that's been a key part of how we've architected our business. And that's how we can also manage risk, right? If any time our technology is not ready, because we're building with traditional materials, right? Like, we can always, right? So we haven't had to resort to stick building, but we can still manually finish those tasks in the factory, right? Like framing. For our first project, we had 25 walls to build. Only 3 of those walls, those designs complied with what the robot could frame. From a timing standpoint, we could only frame 1 wall. Right? We only had 4% completion on the first project. That was a still success because that was less than 6 months since we'd actually commissioned and physically installed the robotic work cell to get a wall that actually went into a customer project. But for this next project we're building right now in October, over 80% of the walls will be framed by the robot. Right? So it's not like a linear increase, it's almost a step change increase, only because we kind of kept that pressure to say things we build have to go into customer projects. But the relief valve for us is we can still manually frame things. Our factory design is compatible to that. We can still manually install things, right? So our whole goal was, right, we're not an autonomous factory. We're a modular micro factory that's agile. Our whole goal is, like, how do we improve labor productivity so we can deliver low carbon homes in a cost effective manner? So to us, our builders are still a core function of our business, right? Like, we still want to celebrate their craft and allow them to hone in on their craft. The tasks that they don't care much for, right? Everything that's behind the wall, like, those are the places we're focusing on automating. And I think that's given us a really good mix for how we think about technology maturity versus the ability to ship. And the goal for us is to always keep shipping product because it's the only way we will keep learning. So now we're ending this year with roughly 1,250 square feet of product that we have built. And for 2025, we have to build 30,000 square feet of product, right? So that's the kind of jump we're making. And the reason we're able to make that jump is because we invested from the very beginning to say, like, let's work backwards from the outcome for how do we deliver homes to our customers at price points and predictable timelines that they want. and kind of work back to make sure our technology and process actually align with it. And that strategy is playing out pretty nicely.
Yeah. No, when you talk about stepwise change in the outcome that you're delivering, it's funny because I've been speaking with a lot of construction robotics firms, right? And going back to what I was saying before and integrating what you just said, if you want to start a construction robotics firm, one of the ways is starting a trade contractor and go out on the job site, build, win jobs, lose some, do the process that basically your manual competitors have been going through. Then at home, there must be someone. It can be you and your co-founder, but there must be someone working on a way to automate these tasks and making this the most efficient process that you can make. Once you're basically at price parity with your competitors without that robot or that automation, that process, whatever differentiates you. When you're there, it just becomes a stepwise function in how much work you get, because at that point you get 50% of the work. If you wanna, try to 50% of the work if there's two players in the market. But then you're gonna get 100% the moment that you go a few dollars below that price point, because this is, the reality is this is a very price sensitive industry, and so you have to prepare yourself to go out and bid for jobs before you can bid for jobs. It's really difficult to work backwards, build a robot, and then start bidding for jobs, because then you have to learn what it means to go on a job site. I think for that reason, access to construction sites, access to information, access to project schedules, this is something that construction companies, large builders that we were talking about, so the right hand tail, those would need to foster to the wider ecosystem and just give out, so that more people can build stuff that is really useful for their own purposes, because they will be able to hire the cheapest trade subs ever, if we allow them to exist. So there's a case to be made that is an ecosystem effort that is needed to push this forward. So I love that the take that you have of, if it's needed, we'll do a manual, but it's not. And then whenever it's needed, and then whenever we're ready with our R&D, we'll do most of the work automated, because we recognize that's where the real value is. There's no point in procrastination on that. You've been, I love what you've done. I think there's something that I want to try to understand, and we didn't double click because I followed my hunch of kind of going down the rabbit hole together with you. There's something we didn't double click on, but now it comes back. You've driven us through the mind of a brilliant process optimization, framework, and I love that. Where did you get these skills? Where did you? How did Kiva and Amazon, foster your growth as a roboticist and as simply as as someone that thinks in terms of tech? How did that go before Reframe, before the two newborns, right? What is it that you learn that you think it's key?
Yeah, that's a really good question, and thank you for the kind words there. I think the surprising transformation that took place for me from Kiva and Amazon Robotics is that it made me less of a roboticist and more of a systems builder. My whole college training was as a mechanical engineer by training, but I was building a lot of mobile robots in college. My first job out of college was in robotics R&D, so I very much identified myself as a roboticist. Joined Kiva, and then very quickly started realizing that the entire value proposition for us to actually bring robots out of the lab and into the market was to make it less of a technology problem, make it more of a systems problem. And I think that's where that initial training and thinking started coming together on how do we think about problems from a systems perspective. And the Amazon acquisition supercharged that learning, because the biggest thing that happened with the acquisition after was it really forced us to think at a scale that we never envisioned before. As a tangible example, we ended up building, today we build, well, I'm not there anymore, but the business today builds more robots in a week than Kiva built for its entire existence before acquisition. And So the first 2 years we were there, like when we were looking at the growth curves Amazon is suggesting, we were like, how the hell are we going to do that? Like, how are we going to go from, we built about 10,000 robots in entire existence as a business before acquisition. And now the 3-year roadmap requires us to build 30,000 robots and launch these really massive buildings. So it really forced this whole thinking on, okay, how do we get better at thinking about the problem and challenging existing assumptions and built assumptions, right? Like, where can we actually change the process to simplify things so we can reduce stop identifying ourselves as a robotics company and more of a solutions provider. Like, how do we actually innovate more? So a lot of the invention that took place for us after acquisition, we've obviously driven a lot of the cost out of our robotic systems over time with multiple generations, but almost all the effort we've made, I'd say, from 2012 to 2020 to the 10 years I was there, post-acquisition, was all in software. Like, we built better worker interfaces. We had better station interfaces for people to become more efficient. But then we also learned the benefit you get. So pre-Amazon, Kiva was selling robotic warehouses to other customers. So we weren't operating the business, right? So we're in the business of trying to harden our product so someone else could operate it. With the acquisition, we basically became part of the same operating company. And that really opened our thinking to the relief valves you have. And that's what you're alluding to on suggesting companies actually become a trade contractor rather than be a technology company initially. Because when you're a technology company, there's so much onus on the performance of your technology and product, right? Because your operator then has to use that to deliver the outcome, that the time it takes to build that hardened product is really long. But when you're an operator, how you deliver the outcome, your customer doesn't care as long as they get the outcome. But it gives you all the time in the world to figure out how to optimize the tech, how do you take shortcuts on your process, but more importantly, how do you take a step back and redefine the process? And that, to me, I think was the biggest learning was, like, it's very typical to look at a problem and say, we can optimize this problem by adding automation or technology in certain areas. You don't have the luxury of taking a step back and say, we're going to redefine the problem or redefine the process, because you don't own that. But when you're actually the owner of the process, now I get to tell my team, right? Because when I think about even the challenges that each of our teams are optimizing for on the technology side or the design side or the operation side, the advantage I have now is I could tell the ops team, actually, you're going to take this haircut and you're going to do something suboptimal operationally, so I can actually increase entitlement on the technology side so we can actually move the curve faster. We would never be able to make the decision if our boundary line was we are selling this tech to a different operations company, because we can't tell that company to change their process. We have to fit into their process. And so I think like a huge learned unlock, which further informed Reframe's approach. And I think you also made the very salient point, right? And I think that's the right way for a lot of tech companies in the construction space to think of is, like, deliver the outcome because it allows you to really change the process and like not have people worry about how the sausage is made. They just get a high quality product at the end of it, but you get all the levers on how you adjust your technology roadmap and your process roadmap to make that work.
Yeah, it's huge learnings. And I think the beauty of these huge corporate monsters that we all hate and love for different reasons. The beauty of what they've been building is that they're from their R&D, and I can think of SpaceX as a huge example. The level and the that mentality of raising the bar every single day is spilled over in the startup ecosystem in completely unforeseen ways. There's a overabundance of whatever alumni that build incredible things, because these companies don't slow down. Their playbooks are playbooks that basically are budgetless. They're almost they're almost bottomless in terms of budget, because the stuff needs to get done and stuff needs to happen. And if 1 year is operating at a loss, but it will take us in a better position for the next 10, it's worth trying. That iteration is one that is viable. It's a possible path of the idea maze to get there. And so I love that you've learned that. And a lot of people, and I hope that this podcast can be a way for founders to accumulate knowledge. And my initial idea for the entire series of BitBuilders is to create this big knowledge pool of cool people that have built cool stuff in the built world that has to do with building and building in a new way, from hence BitBuilders, whatever. That's the name that we could come up with. But I really want to try to end every episode with the same, type of question. One day, I think I'm going to do a collage of all of the witnesses. But I've taken a lot of your time. You have to get to the factory. You're in Boston. It's 9:10. So it's time for you to go to build. But I have a question. What is the advice that you would give founders that are doing their first steps into the built world or robotics, anything that's really hard to do and that's innovating legacy industries?
That's such a good question. It'll be the same advice I'm going to give them that I received from my manager when I was leaving Amazon, which was obsess about the problem and not the solution. And I think that is very true and timeless advice that also helped us as we formulated our approach, which gave us the clarity on the outcomes we have to deliver, because that allows you to focus on like how you build your business. For founders who are technologists, as a fellow technologist, it's very tempting to define yourself based on the solution. And very quickly, you either start drawing arbitrary boundaries on the type of problems you can solve because you've defined yourself by the solution, versus being able to have a more open mind where the technology can change, the solution can change, and you're actually giving yourself a much longer time arc to make sure you're solving a true important problem. So I'm sure it's a cliched statement, but it's still very true. It's obsess over the problem and not the solution. And I think that'll lead to better things.
I love it. And I think it really summarizes the conversations that we had, because you took us really in the depth of the problem. And I love that approach. Thank you so much, because this has been super informative. I'll let you go back to building, and we're looking forward to the next projects that you're gonna spin up. I've had a look, and I really nudged the audience to do so at the first project that you guys have posted infos about in your social. So that's really awesome. But thank you very much for your time.
Thank you so much, Gabriel. Thank you for doing this and giving us an opportunity here. And let's all keep building. I think we're all finally getting onto this movement together, and how we can, in our case, is how do we get more low carbon construction out there? But for everyone else, is how do we just get more homes built or more construction done faster and more predictably? I think we're all in this movement together, and I think the more we can learn from each other, the better. So thank you for creating the forum for it.
Have a great one ahead.
Cool. Thank you so much. Bye.